Welcome to this lecture on urban planning for electric vehicles. In this lecture, we will learn what urban planning is and how parking can be used as an incentive. In addition, we will look at the challenges when planning charging infrastructure and discuss what the modal shift is. Urban planning can be defined as the spatial planning of land use within city boundaries. For electric vehicles, the mobility and energy aspects of urban planning are the most important. Urban mobility planning includes all transport and traffic that occurs within the city boundaries. Electric vehicles will affect urban planning or mobility on many levels. I will discuss three important topics: the effect of the uptake of electric vehicles on parking spots, charging infrastructure, and modal shift. For each of these topics, I will explain to you how they affect urban planning, how EV users are incentivized, and how this affects others without EVs. The development of parking spots is affected by the penetration of electric vehicles. Electric vehicle users will want to charge their cars during parking periods, whereas traditional vehicles depend on petrol stations to fill up their tanks. However, both types of vehicles will have to park their cars. The development of parking spots that can satisfy the needs of both activities is incentivized, and misuse of parking spots is disincentivized. The European Energy Performance of Building Directive, the EPBD3, requires a minimum installation of charging points in new apartment buildings and utility buildings. Municipalities in many countries are using or considering to use warnings and fines to discourage fossil vehicles to park on charging spots either full-time or during certain time slots. Sometimes these municipalities also want to discourage charging point hogging, which describes leaving the car parked for a long time after the charging session is completed. Parking privileges are also used to incentivize the purchase of an EV. For example, by providing discounts on parking fees or by giving the EV user priority on the waiting list for parking permits. Charging infrastructure is an important factor in the decision to purchase an EV, because visible charging infrastructure can increase the uptake of electric vehicles. Challenges in the urban planning of charging infrastructure include the allocation of charging points in the public space, fitting the charging infrastructure within the boundaries of the electricity grid, and creating a positive business case for the charging industry. Allocation strategies include strategic placement, for example, placing the infrastructure near important facilities, data-driven placement, for example, using purchase or charging data to determine allocation of new charging points, or citizen participation, for example, by allowing a request of citizens or by letting citizens vote on new locations using online interactive map. Fitting charging infrastructure within the electricity grid is also a challenge, because the energy transition had led to more electric heating, cooking, as well as electric mobility. It is the responsibility of the grid operator to expand the grid and to make sure all energy demands are met. Furthermore, there is an opportunity to match the supply of renewable electricity with the charging demand of parked vehicles. Charging adaptations such as vehicle-to-grid and smart charging can help by enabling more charging infrastructure under current grid conditions and to better meet the charging consumption with renewable electricity supply. We'll come back to this adaptation in another lecture. Charging point operators sell their charging services to the EV users. However, in cases where charging infrastructure is allocated in spaces with low EV purchase uptake, this can lead to a lack of profitability. Still, it is very important to make charging infrastructure visible and available to ensure the uptake of electric vehicles. This is why many governments are willing to incentivize the installation of charging infrastructure to enable the transition to electric vehicles. Modal shift is the transition from car ownership to alternative modes of transport, such as bikes, public transport, and shared vehicles. For the urban planning of electric vehicles, especially car sharing is interesting. Municipalities are ensuring that more and more of these shared vehicles will become electric, for example, by requiring new providers of shared fleets to become electric before giving out a permit. Free-floating shared vehicles have different charging demand than privately owned EVs. The shared vehicles is charged more often and a wider variety of locations. This makes the charging of shared vehicles less predictable, and their fleets should be taken into account when planning for electric vehicles within city boundaries. This is also the case for professional traffic. For example, cab drivers who are also incentivized by municipalities to electrify, but these users charge more often and more depend on fast charger. So, let us summarize this lecture. We have looked at urban planning for electric vehicles and discussed the implication for EV users and other citizens. The uptake of electric vehicles affects the development of parking garages and on-street parking. Preferential parking and discounts are used as a tool to incentivize the purchase of an electric vehicle. The use of parking spots with charging infrastructure is restricted for those who drive with fossil vehicle, and in some cases, the electric car also needs to be removed after charging to ensure charging opportunities for others. Commercial parties invest in charging infrastructure. In some cases, the infrastructure is subsidized by governments. Other challenges are the allocation of charging infrastructures and ensuring charging under various grid conditions. Modal shift has introduced other mobility patterns in charging, and these should be accounted for in the planning of new infrastructure.